Assalamualaikum to Dr. Nur Hafiza. We are from Group 3. Today we are going to present about our project which is Mini Portable Blender. So first, I would like to introduce our group member. First, we have Ahmad Sahli, Muhammad Akif Farhan, Muhammad Ali Ilmi and also Nur Ain Syuhada. So first, we will look at project overview. So basically in this project, we were required to create a mini prototype of household equipment and make a calculation based on our what we learned in the subject of mechanic or machine. My group member had decided to create a blender as our prototype that will be called as a mini portable blender. The reason why we choose blender as our prototype is because this equipment was one of the household equipment that always used in our daily routine, and it is related to the one of our subtopic in mechanic of machine, which is balancing. So next is introduction. A stationary blender uses an electric motor to power a revolving blade at the bottom of a container. The latter design can blend any container. Common blade material include glass, plastic, and stainless steel. Our prototype will use low-cost and waste product to reduce fabrication costs, ensure stability and durability. So how it works? Blender container with detachable blade should have a gasket or O-ring to prevent leakage. Blender flow through blade supported by a base and motor. Low power blender require a liquid to function properly, as it has particle move and contact blade. Blade create a swirling effect for uniform contact, while powerful blender break ice and ice cream. Next is problem statement and objective. For this project, we can conclude that we have three problem statements that we can discuss. First is to reduce the initial cost of process and cut down on the amount of electricity used by a blender. To create a brand new invention, a tiny portable blender with features comparable to those of a stationary version. Lastly, the product will prioritize easy maintenance and can easily be replaced. For the objective, to fabricate a successful operating prototype of mini portable blender for home appliance purpose, and lastly, to apply the concept of mechanic of machine in the project. So, for the literature review, this chapter is explore the reasons for the design and construction of a mini portable blender, focusing on theoretical and material requirement and the importance of balance in machinery design to minimize unbalanced force.
Hello and hi, my name is Muhammad Ali bin Muhammad Adam. My metric number is DD220086 and I continue the presentation. This is our flowchart. Every member of our group shared their thought and opinion about the issue we had previously settled upon at our first meeting. We all decided to select one of our group idea, making a DIY blender that is satisfied the specific criteria after the concept presentation procedure was complete. This idea is about expanding the range of the household appliance with the use of symbol, shape, and arrow. Each flowchart provides a visual depiction of a system workflow or process highlight the linkage and order of stage. It offers a structured and comprehensible method of visualizing complicated data, making it an invaluable tool in several industries. The creation of a flowchart can show the entire process for the production of our project more concisely and this is our Gantt chart. A Gantt chart is a type of a bar chart that is represent a project schedule. It displays the start and finish date of the various elements of a project. Management for a planning, coordinating, and tracking specific tasks with a project. Furthermore, as a consequence of the meeting, the handmade blender has been selected as a both of prototype and the particular name for our project this this time around. For the need for the ninth week prototype production, we have submitted a number of designs. Data gathering. We use three ways to find information for the production of this project, such as a book, library, and internet. Book. For the guidance in calculating the blade radius balancing system, blade width, and length of the fishing rod. We consult the mechanical mechanic who have maybe learned a great deal which is conduct this study stroke reading, and it may also help us comprehend how mechanics are used in mechanic regular library. Libraries are essential organizations that has big impact on education. Libraries are well known for being significant centers for finding, accessing, and utilizing information. As a knowledge space is often an organized setting where users may locate and vary of those resources. And then lastly, Internet. Additionally, we get the data for our study on Blender, Motokai, and balancing system arrangement for browsing the Internet. Once we get the data, we use it as compilation to create a grander design.
Okay, now for the costing for this project, there's not a lot of money we spend. Most of them are used and recycled. So the thing that we buy is the motor for 8 ringgit and 50 cent, double A battery holder, 2 ringgit, rocket switch, 90 cents, and double A battery. There's four of them, so the total is 850. And the 14 plastic container hot glue gun, and pen. All of these are free or recycled. So for the total cost is 90 ringgit and 70 cent. Okay, then step 4, we make a hole for the rocker switch. There's a triangle on the motor's container and attach it to the container body. And then we connect all the wires from motor to the batteries and the switch. And we measure, next we measure and trace the blade shape into the thin lip, and we cut and bend it into a blended knife shape. And then we cut the pen into the what thing into a small tube and attach it to the motor and the motor shaft and the blade using hot glue. And last but not least, the blender is ready and finished assembly and ready for testing.
For the calculation part, the test one, for the blade that we use is 4 blade, and the mass is 5 gram for each blade. The radius for the blade is 2 cm for each of the blade, and the force is 10 gram centimeter, and the angle for first blade is 0, second is 90 degree, third is 180, and lastly 270 degrees. And as the result we can see in the graph paper here, the result is back to the origin or balance. And for the test 2, we can see that the number of blade is also 4, but the mass that we use is 7 gram, and the radius is 3 centimeter. For the force is 21 gram centimeter, and for the angle that we use for first, second, third, and fourth is same with the test 1, that is 0, 90, 180, and 270 degree. For the result here, we can see that for the test 2, the result is also back to origin and balance. For the discussion part, The chapter primarily discussed the outcome of tests involving different blade configuration. It emphasized the importance of accurately estimating project outcome based on the test. Another key focus is on understanding and utilizing balancing mechanism within the system. This includes analyzing static force diagram to achieve balance, particularly in configuration involving blade at different angle and mass. The result indicate that using two blades of equal mass and parallel alignment effectively balance static force in the system. This finding underscore the practical application of experimental data to optimize blade configuration for stability.
So, in conclusion, from this project, we can enhance our understanding of balancing in mechanical automation and learn how to work in teamwork. Also, we have successful to create a mini portable blender prototype. For future research, we suggest to using stationary blender or stainless steel blade for crushing hard material like bean, garlic, with a pan as the motor shaft and stainless steel iron as the shaft for rust prevention.